Okay. Let's have let's have an example on how to solve for the moment of inertia. Okay, determine the moment of inertia of the shaded area with respect to the y-axis. Ito yung y-axis natin. So this is the composite area. Okay, or built-up section or steel design. No? So this is a composite area. Ito mayroon tayong rectangle. Then yan, so yung configuration niya. So how do you solve for the moment of inertia of the shaded area with respect to the y-axis? Ito yung y-axis natin. So obviously nasa center siya. Y-axis. Okay? So y-axis. So ang gawin natin, since we have a composite area, ang meron lang tayo na formula ay yung mga regular shapes, rectangle, triangle, circle. Yung formula natin for moment of inertia. So we're going to do is to divide, we divide yung ating composite area into regular shapes. No? So medyo obvious naman na kung paano natin i-divide yan. So ito yung same thing rectangle dito. Okay, division natin. So we have 3 rectangles here. And let's say this is area 1, area 2, this is area 3. And then locate now the centroid of each area. So yung centroid natin for area 1, of course, nandito. Let's say C1. Area 2, nandito sa mismong center ng buong section. Okay? So 24, 24. So basically this is C2, and that is also O or no, C2 yan. This is C3. So dito yung center. Ito yung y-axis natin ay nandun mismo sa center ng buong section. So symmetrical naman. So if you try to look into the center line, symmetrical siya. So medyo obvious kung nasaan yung center ng section with respect to the vertical axis. Okay, so why this is y-axis, ano? So kapag you look at the centers, no, yung center ng buong section, center ng bawat at saka yung center ng bawat shape, okay, or area. Okay, so pag magkaka-align yung mga yan, if they are aligned, tingnan nyo lang. Okay, magkaka-align lang yan. So, ibig sabihin, yung moment of inertia ng buong section is just the sum of the moment of inertia of each individual area here. Okay? But, if you are going to consider now yung x-axis, no? Di ba, i-solve mo yung moment of inertia niya about the x-axis. Yung center, ito yung x-axis, ha? Okay, nandun yung center ng buong section. Okay? Okay. So, yung center ng buong section, ay yung center ng area 1, hindi siya magka-align dun sa may x-axis. Okay? Yung center ng area 2, yun lang, naka-align lang siya doon. Okay? Yun lang ang naka-align. And then, yung center naman ng area 3, hindi siya naka-align sa may x-axis. So, if that is the case, then we are going to use the parallel axis theorem. Okay? So, or the transfer formula. That means we're going to transfer yung area 1, yung moment of inertia ng area 1 dito sa x-axis, yung moment of inertia ng area 3 sa may x-axis. Okay, but since the problem is asking us to solve for the moment of inertia about the y-axis, ito, in which yung mga centers, yung center ng buong structure or yung section, center ng area 1, center ng area 2, center ng area 3 ay magkaka-align. That means we do not need to use the transfer formula. I mean, the moment of inertia of the whole section is just the sum of the moment of inertia of each section. Okay? So, very simple. Ano ba moment of inertia natin for rectangle? So, meron tayong tatlong rectangle. Ano? So, we are solving for IYO. At least the moment of inertia about the centroidal y-axis. So, b cubed h all over 12. So, yung base ang cube, no? So, let's start with, so yung IY natin is equal to IYO1 plus IYO2 plus IYO3. Okay? So, yung IY natin is equal to, what is IYO1? B cubed H all over 12. So, ito. B cubed H all over 12. Base natin is 24 plus 24, that's 48. H natin is 6 all over 12. Okay? Plus, IYO2. Ano yung second area natin? Ito. So, B cubed H all over 12. Ang base natin naman dito ay 8 mm cube. H natin is 48, ano? All over 12. Plus IYO3. Ano na naman yung IYO3? Ito. So, B cube H all over 12. So, ang base natin is, so 12 plus 12, that's 24. H is 6 all over 12. Okay? So, yan na yung moment of inertia natin about the y-axis, which is equal to, ilan yun? 64,256 millimeters to the fourth. Okay? So, that's how we solve for the moment of inertia. Yeah. Dali lang, ano? Dito ko lang. Sige, next na problem, example. Eto, let's try this one. Determine the moment of inertia of the composite area about the y-axis. So, y-axis ulit. Ito, y-axis natin. Okay? So, again, we have to divide the section into regular areas or regular shapes. No? So, obvious naman na, parang na-divide na rin. No? The axis already na-divide na, no? Okay, so y-axis lang ang i-compute natin ng moment of inertia. So, relative to y-axis. No? So, it's not the center, but we are to solve for the moment of inertia of the whole section relative to the y-axis. So, ano gagawin natin? No, ang nasa module nyo ito, no, the solution is very simple. It's just application lang yun ng mga formula natin, derived formula. But I'll show you a different way to solve this one. Okay, using yung transfer formula or the parallel axis theorem. Okay? Para yun lang ang memorize yun na formula. Yun lang. Okay? Okay, so what we're going to do is, so yung una, of course, divide natin yung section into series of regular shapes. And then identify the center of each section. So ito yung center niya. So this is section 1, section 2, section 3, then section 4 itong triangle. So this is C1, C2, C3, and C4. Okay? So, ang gagawin natin sa transfer formula, ano ba na ulit yung transfer formula or yung parallel axis theorem? IO is equal to IC, yung centroidal moment of inertia ng isang section, okay, plus AD squared. Okay? So, which means na ang bawat moment of inertia, yung centroidal moment of inertia ng bawat shape na ito, i-transfer natin dito sa may y-axis. Okay? Transfer natin yan about the y-axis. Okay? Okay. So since we need yung tong D dito, ano ba tong D na yan? It's a distance between the centroid of each section from the y-axis. Okay. So, kailangan natin yung distance ng bawat section from the y-axis. Let's say this is D1. So, from the y-axis, this is D2. And this is D3. And this is D4 na lang. So obviously D1, D2, and D3 are the same. No? So D1, D2, and D3. So yung D1 natin is equal to D2 is equal to D3. Since square naman yung mga shapes na yan. They also have the same area and basically they have the same moment of inertia. Okay, so ilan to? Half nito, no? So yung center, so 150 divided by 2, that is 75 millimeters. No? How about D4? D4, distance ng centroid ng section 4 from the y-axis. So anong ilan yan? Yung distance na yan. So ilan yung distance na yan? That is 1/3 of 150. So ilan yung 1/3 ng 150 divided by 3? That is 50 millimeters now. Okay, so we're good. So IO then is equal to IO tuloy. IY I should say is equal to, so yung area 1 i-transfer natin siya dito. So that would be, okay, so IXO1 plus A1 D1 squared, okay, based from the parallel axis theorem. IX tuloy, sorry, IY pa rin. IYO1 plus A1 D1 squared, okay, plus ganun din yung gawin natin. IYO2 plus A2 D2 squared plus IYO3 plus sorry, A3 D3 squared plus lastly we have IYO4 plus A4D4 squared. Ayan. So, yun yung working equation natin. So, solve na natin. So, i-substitute na natin yung mga values. So, IY is equal to, what is IYO1? So, square yan. Rectangle, no? Formula natin. B cubed H all over 12. So we have square naman, so 150 cubed times 150 all over 12 plus area is 150 squared kasi square siya, or 150 by 150 times D squared, D1 squared. D1 is 75 millimeters. Actually, pwede mo nang i-times 3 ito kasi pare-parehas lang naman yan. Pero just for the sake of the discussion, para tumugma yung equation natin dito sa next step. So 150 cubed times 150 all over 12 plus 150 squared times 75 squared. So pare-parehas lang yun yung mga first, second, and third terms ay pare-parehas lang yan. Okay. So we have 150 cube okay. Next, area 4 naman. Ano yung moment of inertia ng area 4? So for triangle, that is BH cube all over 36. So ang base natin, of course, since y-axis yan, ito yung base natin. Although, at saka yung height natin is parehas lang naman, 150 rin. So, so BH cube all over 36. Ang base natin is 150. Height is also 150 cube all over 36 plus AD squared. Area, of course, is 1/2, 150 by 150. Okay? Times D squared, D4 squared. Ang D4 natin is, we have identified it a while ago, that's 50 mm squared. Okay? So, yan na yung ating equation. Now, we can now solve for IY. Okay? Okay, so the answer is, answer natin, 548. 548.34375 times 10 raised to 6. No? So ito na yung IY natin. Using the transfer formula. Okay? Using the parallel axis theorem. Now, the one in the module, yung sa module ninyo, iba yung solution niya. Okay? So, although you can also use that, pero ang point ko lang is that para ang i-memorize na lang natin ay yung yung mga centroidal moment of inertia ng mga sections, and then in case na mag-solve tayo ng moment of inertia about a certain axis, then we can just use the transfer formula or the parallel axis theorem. Okay? I think sana naintindihan natin paano mag-solve ng moment of inertia. Okay? So, kailangan ma-master natin to para sa next subjects natin ay may apply na natin ito, no? Sa hydraulics, ano pa ba? Sa strength of materials or mechanics of deformable bodies in your design subjects. Of course, this would be very helpful para hindi na kayo mahirapan mag-solve pa ng moment of inertia. Okay, so we'll have more examples na lang sa next na videos.